The demand for monorail service in Las Vegas in 2005 can be approximated by Q equals negative 4,500 P plus 41,500 rides per day when the fare was P dollars. What price should have been charged to maximize total daily revenue? We are asked to optimize, specifically to maximize the daily revenue. So we need to come up with the revenue equation. Recall that the revenue equals the price times the quantity. And so the revenue equation R equals the price is P and the quantity is already in terms of P given negative 4,500 P plus 41,500. Expanding this equation, we have R equals negative 4,500 P squared plus 41,500 P. P is the price, and we can assume that it cannot be negative or zero even. So P is strictly greater than zero. Next, we will find any critical point by taking the derivative of the revenue function. Negative 4,500 is the constant multiple, so we would rewrite this. The derivative of P squared is 2P. The derivative of 41,500P is 41,500. And so the derivative R prime equals negative 90,000 P plus 41,500. To find the critical point, we set the derivative equal to 0 and we solve for P. Negative 90,000 P equals negative 41,500. And so P equals negative 41,500 divided by negative 9,000. And this will give us 4.611, or we round it to $4.61. Now, how do we know that this price will maximize the revenue? We can check using the first derivative test. The critical number that we found was 4.61. If we pick any number in the interval between 0 and 4.61, for instance, if we pick P equals 2, and we plugged it into the derivative, we will see that negative 90,000 times 2 plus 41,500 will give us a positive number. So the derivative is positive in this interval. Similarly, if we pick any number in the interval 4.61 to infinity, we will see that the sign of the first derivative will be negative. In this case, we plug in 5 into R prime. Negative 90,000 times 5 plus 41,500 will be negative. What this is telling us is that the revenue function is increasing up to 4.61 and then start decreasing. This gives us the maximum value. They should charge $4.61 per ride.